Okay, why does our multiplication algorithm work? You can find other videos online about examples with carrying and bigger numbers, but let's just talk about why it works. And we're going to go back in history to the days when ancient kings and queens would have scribes, and scribes would have slaves that would do things for them, and we're trying to do processes that don't require more than specific training. And the specifics on the left, we're assuming that our people have memorized their times tables up to 10. So if I say, what is 6 times 6? Then my scribe who's a slave can say 36. We also know the rule that times 10 means put a 0 after something. So 3 times 10 is 30, 9 times 10 is 90. And because 10 times 10 is 100, we can repeat this. So if I say, what is 3 times 100, I'll know it's 300. I'm just putting 2 tens after 3. Okay, I'm gonna, whoops. Pause the recording. So 9 times 100, I can do that. Or 9 times, yeah, it would be 900 because I put the 2 zeros after 9. And notice this requires a writing in base 10. So if you study the history of cultures that didn't have base 10, then they have different multiplication algorithms, which is interesting, but not this lecture. So if I want to multiply 12 times 34, using those 3 foundations that are written on the left in red, then I have to break things apart. Because I don't know my 12 times tables. I don't know my 34 times tables. So I will take my 12 and write it as 10 plus 2. Instead of making 12 copies of something, I'll make 10 copies of something, and I'll make 2 copies of something. And then together I'll have 12 copies of something. And similarly, for my 34, I'm going to write my 34 as 30 plus 4. So whatever it is I want to make 34 copies of, first I'll make 30 copies, and then I'll make 4 copies. Everyone okay with that step so far? So each of these boxes, like we're playing the game Battleship, is where something happens. Let's start with the easy one. I want to make 4 copies of 2. I can do that. I know my times tables for 4 and 2. 4 2s is 8, 2 4s is 8, something like that. How about this box? 4 times 10. I know that from this rule. I'm just going to put a 0 after my 4. How about this box? 2 times 30. I have to, following these rules, because remember, I'm not assuming I can do 2 times 30, even though it might be easy for us to think 2 30s is 60. We're pretending we don't know 2 30s is 60. I'll have to take my 30, peel off the times 10, say, oh yes, this is really 3 times 10 here. Then I can do 2 3s is 6, and then put the times 10 back on. So 2 3s is 6, put the times 10 back on. That's how the methodical scribe would think about it. The computer would think about it. And then lastly, what's 10 times 30? That's put another 0 after 30, and I would get 300. If I add up all of those, then I would get 408, and that's my answer. Because I've made copies of all the different parts, and then I smush them together. One reason I'm showing you this is that this is a lot of what our kids are taught to do these days in elementary school. If you have an elementary school age kid, they probably have made little arrays like this because for some reason this is popular. Okay, questions about just this middle part of the screen? Okay, now most of us would write this as 34 times 12. And the same thing happens, but we're going to write it more efficiently. So 3 times 4 is 8, and that's the same 8 that we have here. That was 4 copies of 2 or 2 copies of 4. Then we have 3 times 2 is 6, and we know we're supposed to write it here. But that's again because this 3 isn't a 3, it is a 30. So that is this box here. That's 2 copies of 30. 2 copies of 30 is 60. Then we move to the next row because we finished with the 2. And depending on where you grew up or what decade you grew up in, maybe you were taught to make an X here. Maybe you were taught to put a 0 here. Maybe you were taught to kind of shade it in. There's different styles. And the point of all of it is let's ignore this and scoot over. I'm going to go with a 0 because I'm guessing most of us were taught to use a 0. But this isn't a 0 because I multiplied something and had a 0, like 5 times 2 is 10. This is just remember to scoot it over 0. Then I go 1 times 4 is 4. And that box is this one. That was 4 copies of 10. 4 copies of 10. This is scooting me over because this 1 isn't a 1, it's a 10. And then lastly, 3 times 1 is 3. And I'm running out of colors. What am I doing? Green. So that's this box. I'm taking a 10 times a 30, and I'm making 300. And again, when I'm done, let's make that screen. I have to add them up, and I will get 408, and that's my answer. So the thing that most of us were taught growing up is just a more efficient way to write what a lot of our kids are being asked to do in school today. Does that either help you if you had this question Wednesday, or help you if you have a kid in elementary school, or was just interesting and colorful?
I'm just glad all my kids are grown up and out of school.
Oh. Okay, I prepared the slide to do another one if anyone wants, but I'm guessing 1 is enough. Anyone want to see this? No. Okay, so we'll be done with this and go back to geometry. But while we were doing rectangles and multiplication, this was a good place to squeeze it in as this kind of mini lecture.
Could you actually do one more? I'm sorry, I'm just really lost.
Sure. Although if you know how to multiply, then that's good. The fact that you can also draw it in a way that takes more drawing is not important. So if you are happy just to do this way, let's do this first and just get it done. How about that? So if I have 302 times 123, whoops, I'm going to need more boxes down here. I didn't prepare my slides right after all. I know what to do. Okay.
It doesn't matter which number goes on top, correct?
It doesn't matter at all. Just like here, it doesn't matter which one I wrote on the top or the side. Okay, 3 times 2 is 6, 3 times 0 is 3, 3 times 3 is 9. That was all dealing with the 3. Then I put in some sort of, let's ignore this spot, because the 2 is really a 20, so I need a times 10. 2 times 2 is 4, 2 times 0 is 0, 2 times 3 is 6. Then I'm going to put in 2 kinds of, let's ignore this spot, because this 1 isn't a 1, it's a 100. It has 2 times 10s. 1 times 2 is 2, 1 times 0 is 0, 1 times 3 is 3, and then when we're all done, we have to add things up, and we'll get 6, 4, 11, 7, and 3. So if you can do this, you're great.
There was a
No one in real
slight-
life, except maybe your kid's elementary school teacher, cares if you can draw it as a box.
There was a slight lag to like what you were saying as you were drawing it, so I just want to make sure that I understood how you were doing it. You're just taking the farthest rightmost number on the bottom, and then you do all 3 numbers at the top one at a time, and then you go over to the left, do the same thing, and then go.
Yep.
Over.
And I've designed these problems to not have any carrying. They get a little more complicated if you have to carry, but that's about carrying. That's not really about the multiplying. Does anyone want me to do it with the write a lot of box stuff method also? Would that help you with kids in school or something? No. Okay, let's skip over that. And if you look at the Now Calculator test, you don't actually have to do this. So it is a good skill to be able to multiply things in case your power goes out, but it is not a priority this term. We probably have bigger issues to deal with. Okay, stop that recording.